Happy Cinco de Mayo, everyone. And if it's not Cinco de Mayo for you, which odds are it's probably not, it is for me. Here we go. Last lesson, we got our toes wet, dipping into the functions pool. Now we're going to go out a little bit further and work with domain and range, something that's going to pop up a lot this unit in future units and next year. So we're going to learn how to properly state the domain and the range for a variety of functions presented in a variety of ways. So starting with domain. From now on, when you see the word domain, you should only be thinking independent variable. To simplify that even further, you should only be thinking x-axis. Specifically speaking, the domain is the set of all values for which x can be, or the independent variable, because it's not always going to be x. There is a very specific format for this, and you have to follow this format. If you don't follow this format, then you get put on Math Santa's naughty list, and you don't get math Christmas presents. So we're going to start here with capital D for domain, then a colon. So I'm going to label as I go. D for domain, colon, don't have to label that. Now you got to practice your best curly bracket. Something like that. That's actually not bad. Almost like I've been practicing. And then you're going to see this weird kind of XER. So X, this weird looking E symbol, and this weird double line capital R. So that letter X is the letter of the independent variable, which is almost always going to be X. But if it's not X, you would label it something else. If it happened to be, I don't know, A and B, and A was the independent variable, then you'd put an A where the X is. So let's label this as the independent variable. That weird looking E symbol, that stands for element of. That capital R with the double line, remember there's different sets of numbers. There's the set of integers, there's the set of imaginary numbers, which you'll get to in grade 12. There's the set of real numbers, there's the set of rational numbers, and many more. So this capital R stands for the real number set, meaning it can't be imaginary numbers. And then you do a straight up and down vertical line, like that. And that just means such that. And then after that, you fill in some stuff. Now we're not actually going to write stuff in there, but and what goes in there, that stuff is dependent on the type of function we have and the representation of that function. And then you got to end that with your best close curly bracket. Often this one to do in the opposite direction is a little bit harder. And that is how from now on, whenever you do domain, you have to have every single piece in that format. And you don't want to get put on Santa's naughty math list. Now we're going to switch gears. Range. From now on, so domain is X. If you had any guesses, range is the dependent variable, which is Y almost always. Very, very similar setup, but if you could guess, instead of D for domain, capital R for range, your best open curly bracket, instead of X here, because it's for the range, the Y values, it's going to be Y. Weird looking E symbol. Set of real numbers such that some stuff, which you're never going to write stuff, and then a closed curly bracket. Now I'm not going to label everything here because it's the same as the domain, but format exactly the same. So range, Y is an element of the real number set such that blah, 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 blah. And now we are just going to do a bunch of practice questions. But first, I'm going to give you a quick visual. So this is a good visual. That blue thing is a graph. And what you always have to remember is the domain is your horizontal movement. So think of it as left to right. What are the boundaries from left to right? Where does your graph exist? Looking left to right only. Range, though, flips that. Range, we are only looking at up and down. Vertical, where does your graph exist? Where are the barriers moving up and down only? So domain, left and right, range, up and down from now on. For our first example, we are given a set of points. Do not connect those points. If they're meant to be connected, I would have connected them. Because when they're connected, how you do domain and range is very, very different. So this is just a set of 4 order pairs. So we're going to start with domain. Capital D, colon, open curly bracket, X is the element of real numbers, such that. Now X, if you look at your function, there's only 4 dots. X can only be 4 things. It can only be 1, 3, 4, and 6. It can't be -1, it can't be -2. There's no points over there. It can't be 1.5. It can't be 1.1. There's no points there. And the line, there's no line between them. If there was a line between them, that would tell you that moving left to right, okay, from 1 to 6, X can be anything because they're connected, but they're not. X only exists at 4 specific points. So how you take care of that, how you tell the reader what the domain is, X equals, and it only equals 4 specific points, 1, 3, 4, and 6. So you would write 1, 3, 4, 6. Close curly, oh, that was terrible. Close curly bracket. Range. Open curly bracket. Y is the element of real numbers such that, same idea here. If these were connected, then you could say Y is anything between -2 and 5, but that's just not the case. Y can't be -4, Y can't be -1, Y can't be 3, Y can't be 4. It doesn't exist at those points. Y only exists at 3 specific values, -2, 2, and 5. Now, if you're thinking, well, 5 happens twice, could I list 5 twice? You could. You're not wrong. It's redundant to write it. You wouldn't lose any marks, but it only has 3 specific values. So Y can only be Y equals -2, 2, and 5. Close curly bracket. There's your domain. There's your range. That's everything X can be and everything Y can be. Next example, and I'm gonna add something to this. We're gonna add arrows to the end because if I don't have arrows, that changes things. So I'm gonna add arrows to the end. Now those arrows indicate that my graph continues onward and upward forever to infinity and beyond. Domain and range. So let's start with domain. capital D, colon, open bracket, x is the element of real numbers such that. Now remember, x is left and right. So if you're looking at it, first of all, this is a continuous function. It has all of the points in between 3 and -3 included. So it can be anything between -3 and 3 for sure. Now those arrows, so if we didn't have those arrows on there, then that's where it would stop. But those arrows, they're pointing up, and they're pointing up on an angle. So this is going to keep getting higher and higher and higher, but it's also going to keep getting wider and wider and wider. Now it doesn't fit on my graph, but if I went for my scale to be like hundreds, thousands, millions, it is going to exist at that. That's eventually this blue graph will hit 4, it will hit 5, it will hit 6. As it moves out to the left, it's going to keep getting wider. It'll hit -4, it'll hit -5, it'll hit -7. So x is going to keep getting wider and wider. There, in fact, is no limit. There is no boundary. There is no restriction on what x can be. That's going to keep growing and growing forever. It's going to keep getting wider and wider forever. That means x can be anything. So if x can be anything, that just means that we don't even need the such that symbol. So we're going to erase that because there are no restrictions on x. There are no restrictions on the domain. X can be anything. So we could just close the curly bracket. That's it. That's perfect. And in fact, for a lot of functions, especially ones that have arrows on them, x is not going to be restricted, especially for quadratics. That's a quadratic, that's a parabola. It's going to be all real numbers. My range is definitely restricted. There's definitely values I can't be. So looking at my blue parabola, it only goes as low as 2. Again, we're only looking at the up and down now. So y can be 2, it can be 3, it can be 4, 5, 6. It can be 100, it can be a million, it can be 100 billion, it could be a quadrillion, it could be infinity, right? Those arrows mean it's going to keep going on forever. It could be 2.1, it could be 2.01, it could be 2.000001. However, 2 is as low as it gets. Can't be 1.9, can't be 1.99, can't be 1.8. Can't be 1, can't be -1, can't be -1,000, right? My blue graph doesn't go down there. It doesn't. The lowest it gets is 2. So how do I take care of that? We have to take care of that with what's called an inequality, which is a greater than or less than or equal to sign. So if 2 is as low as it gets, another way to say that is 2 or above, 2 or greater. So y has to be greater than or equal to 2. Close curly bracket. Now if you need a quick refresher, this is less than, this is greater than. If you see that with a line underneath, that's less than and equal to. And if you see that, that's greater than or equal to. So this gets as low as 2 and it actually hits 2, so that means it can be greater than or equal to 2. Our next example, still find domain and range. This is a line, this is linear, and it has arrows on the end already, we don't have to add those. So domain and range. Domain, left and right. Those have arrows on the end, meaning it's going to keep going up and keep getting wider. And as I go to the left, it's going to keep going down and keep getting wider. All those points are connected. That means all the points in between exist, and as you go out to infinity or negative infinity, they also exist. There is nothing x can't be. X is going to be the entire horizontal axis as far as you go in either direction. No restrictions, no limits, no barriers. X is all real. So X can be anything. My range, same idea. This is going to keep getting, as I go to the right, higher and higher and higher. As I go to the left, it's going to keep getting lower and lower and lower. As you move vertically, there's going to be no gaps, no restrictions, no barriers. All of the y coordinates are going to exist. They're all going to exist on that line. So there are no restrictions. Y is all real, close curly bracket. Okay, now we have a circle. So we definitely have restrictions, and we're going to pretend that the circle, for some reason, it was supposed to go through -3, but it went a little bit beyond that. So we're going to pretend, we're going to use our best imagination skills. We're going to pretend that that actually goes through -3 and -3 on the y-axis. Just so we're not saying like -3.1 and so on. Okay. Our domain. Open curly bracket. Hopefully you're getting good at them now. All real numbers, such that. Now, X, domain, moving left and right. I can be 3, I can be 2, I can be 1, 0, 1, -2, -3. I can be any number in between, right? I can be 2.5. Yeah, sure, there it is right there, 2.5. That touches my graph. I could be 1.01. Sure, right there. Could I be 4? No, I can't be 4. My graph doesn't go any further to the right beyond 3. Could I be 3.5? No. 3.1? No. Moving out to the left. Could I be -4? No, my graph stops at -3, moving to the left. So I am bound between two barriers, one on the left, one on the right. So when I'm going left to right, when I'm going from here all the way across, I only exist between -3 and 3. So I can be any number between -3 and 3. How do you write that? Any number between -3 and 3. So here's what you do. You start with your lowest number first, which is -3, right? -3 is definitely lower than 3. So you write -3, then you write a less than or equal to symbol, x less than or equal to, and then your biggest number, which is 3. Close curly bracket. So how do you read that? That's called a double inequality, and you should get used to that because you're going to see that happen a lot. You use that when you are bound between 2 points, which in this case we are bound between -3 and 3. How you read that is -3 is less than or equal to x is less than or equal to 3. If you go piece by piece, -3 is less than or equal to x. Okay, that makes sense. -3 is less than any of my x values. Then you go to the next half of it, and x is less than or equal to 3. Okay, x has to be lower than 3. Perfect. For the record, I would stick to this to get practice with it. You could do the bigger number first, so you could do 3 and -3 on the right, but then your inequality would have to flip, so you would use greater than symbols. One thing is for certain though, your inequality symbols should be pointing the same way, so you should never have a less than mixed with a greater than, ever. And if you do, that's going to, again, you're going to get added to the naughty list. Range. Very, very similar. Y is the element of the real number set such that, now again, up and down, I only exist between here and here. I can be anything between 3 and -3, but I can't be beyond those. I can't be 4. My graph doesn't go up there. So I only exist between 3 and -3. So it's the exact same idea. So maybe just for contrast, I will write it with the larger number first. So 3. But as I told you, if you want to start with the higher number first, your inequality has to flip. So it's going to go that way. It's range, so common mistake here, people just go fast, they write x again. Don't forget it's y greater than or equal to the lowest number and end curly bracket. So 3 is greater than or equal to y. Okay, so 3 is the biggest, and y is greater than or equal to -3. Okay, y has got to be bigger than -3. Perfect. Like I said, I would, if I were you, just to get practice, I would stick to this one, this format, doing the lowest to highest. But if you decide you want highest to lowest, that's fine too, just your inequalities have to flip. Domain and range from a mapping diagram. Remember from your last lesson, this is a mapping diagram. So this just tells you the coordinates. So like 3, 10, 2, 8, 1, 6. So again, if you were to graph this, this is just graphing coordinates. You would not connect the dots. These do not connect. If they did, you'd have to have an infinite number of numbers inside each one of those ovals. So this only exists on the x, 3, 2, 1, 0, -1, and 2. And on the y, it only exists at 2, 4, 6, 8, and 10. So very similar to our first example, domain. X belongs to the element of real numbers such that x can only equal specific things. It's good math format to start at the lowest and go to the highest, but if you want to be random and randomize them, you can. If you want to start the highest, you can start the highest, but you just list them. -2, -1, 0, 1, 2, and 3. And close curly bracket. Range, same idea. Again, you can't list this with a double inequality because that implies that any number between 2 and 10 exist, which they don't. Only 5 specific values exist. 2, 4, 6, 8, 10. All listed with commas. And then close curly bracket. That was a nice one. Our next example, I've actually listed all of the coordinates for you. Again, you don't want to list this as an inequality or a double inequality because that implies the infinite amount of points between them exist, which they don't. You never connect points unless you are told to. So this would just be a series of this basically would be a scatter plot, right? So, or actually I shouldn't say that never, or if you were using a table of values, but you got the table of values from a function. Like if I gave you y equals x squared and you use a table of values to come up with some points, those points came from a function, a relationship, which means all of the points in between exist, even though you didn't actually do a table of values with an infinite number of points in it. So I guess I should make that clear to you. But this did not come from a specific function. I just listed a bunch of points. So we're going to start with domain. X is the element of real numbers such that, and you just list. And I'm going to go lowest to highest, but that doesn't matter. So you're only looking at what the x coordinates can be, which it looks like it can be -3, -2, -1, 0, 1, 2, 3, and 4. And close curly bracket. Range. Y is the element of real numbers such that, same idea, it only exists at specific values. Y equals -4, it looks like. I got a -2. I got a -1. 0, 2, 3, and 4. Close curly. As I mentioned, if you have repeat values, you certainly could repeat them in the domain and range. It's not going to be marked wrong. It's just extra writing. Why bother? So we've done a lot of practice with domain and range and coming from different representations of relations and functions. The only way you're going to get good at this is by practicing. This is definitely practice makes perfect here. So that's it for this lesson. There's some C work. Again, make sure you reference D2L, not necessarily these questions. Sometimes I take stuff out, sometimes I leave it. And then we're going to get moving into some graphing in the next lesson. Thanks for listening. Talk soon.